Hello, good morning, students. In the lecture number 16, yesterday we have studied about the mechanism of micellar catalysis, and we have studied that organic compounds, particularly non-polar organic compounds, can also be absorbed on to or into the micelle. Thus their solubility relative to water is increased. That result in change in their chemical reactivity. It is micelle rather than surfactant that result in alteration in the rate of chemical reaction in aqueous solution of surfactant. Depending upon the type of micelle, concentration of H ion or OH ion around system layer increased, which is responsible for increased rate. There are three types of micelles: cationic, anionic, and zwitterionic. First, we study the example of cationic micelle. This 2,4, you can see in the diagram, in the equation, this 2,4-dinitrophenyl phosphate is rapidly hydrated at pH of 8, which is basic pH, by cationic micelle. For example, formula of this compound bis 2,4-dinitrophenyl phosphate, we can see that phosphate group is attached there, and from if we count number, we can they see that nitro group is present on second and fourth position, and PO2 group is outside the bracket. In presence of cationic micelles, this this compound is ionized to form O negative ions, 2,4-dinitrophenyl phosphates में से PO2 group is separated and O negative ion is formed. And the second molecule, two molecules are consumed in the reaction, and the second molecule, the 2 and 4 dinitrophenyl groups are present at their positions, and at phosphate junction, O junction, O negative ion is there, and PO3 group is attached here. In case of anionic micelles, inhibits the rate of such reaction due to repulsion with OH ions. Second has zwitterionic micelles. Rate increases due to zwitterionic molecules of reaction such as decarboxylation. So if we take a benzene ring, basically toluene, in which one group is replaced by CN and another group by COO negative, then CO carbon dioxide is released, and a compound like intermediate compound benzene ring attached to CH and CN with negative charge is formed. This, with fast reaction in presence of acidic medium, is converted into benzene CH2CN, a cyanide. Thus, it is clear that catalytic effect can be produced by incorporating reagents into micelle because of increase in effective concentration and resulting reduction in entropy loss in transition state. First है favorable hydrophobic interactions increases effective concentration. There is no problem in explaining inhibition of biomolecular reaction in terms of proximity effect, because if micelle take up one reactant and excludes the other, the reaction will be inhibited, but bringing reaction together does not guarantee rate enhancement, because biomolecular reaction in the micelle may occur more or less rapidly than in water. Thus, micelles can be considered as a reaction medium distinct from the bulk solvent. Now, we see the kinetics of micellar catalysis. In this, if we see the graph between reactant and the surfactant, then it is a straight line passing through origin. It is a first order in aqueous medium. And in if we plot a graph between rate and DN-CMC is this is the critical micellar concentration, and DN is aggregate of the surfactant. Then again there is a straight line passing through origin. Third case, this straight line passing through origin, it shows a depression. For the explanation of kinetic feature of Mizel catalyzed reaction, various types of models have been suggested. However, so far as first order reactions are concerned, the pseudo phase order model is considered very convenient in the kinetic studies. In this model, it is assumed that a missile can be regarded as a submicroscopic aggregate which behaves as if it were a separate medium with its own properties. It is not considered as a aqueous solution or a solvent. It is considered as itself as it behaves as if it were a separate medium with its own property. Thus, we regard that reaction occurring either in the aqueous phase or the micellar phase, pseudo phase, with reactants being rapidly equilibrated between two pseudo phases. No doubt, pseudo phase model has certain limitations, but still considered to be the best model to explain micellar catalysis. Then next we study the kinetics of unimolecular reactions. If pseudo phase model is taken into account to explain the kinetics of unimolecular reaction, it is definitely a very simple and successful approach for the kinetics of unimolecular reactions catalyzed by Mizel. Based on pseudo phase model, the reaction scheme for unimolecular reaction can be given by the following model. Dn plus Sw with a rate constant of Ks is converted into Sdn. This with rate constant of Km is converted into product. Then Dn with Sw with rate constant of K dash W is converted into product. Here Dn is concentration of surfactant. Sw for substrate. SDN is micellized substrate. Km rate constant for the micellized substrate in micellar phase, and K dash W is rate constant in aqueous phase. If this scheme is taken into account and let Ks be binding constant of substrate to the micelle, the following rate equation is obtained. K psi is equal to Kw plus Km Ks in bracket concentration of D minus CMC bracket close divided by 1 plus Ks into D minus CMC. This is equation number 1. Then M plus L with rate constant K1 gives ml. This ml with K2 gives product. Rate is equal to K into concentration of ml, and rate is equal to K small k rate constant capital K ml. This is equation 2. Let mt be the total concentration. Then mt is equal to m plus k into m into L concentration, or m T is equal to m is taken as common, and in the bracket we have 1 plus k into L concentration. Therefore, concentration of m comes out to be concentration of mt subscript plus 1 plus kl. This is equation number 3. From equation 2 and 3, we get rate. This is equal to k small k capital K mt into L upon 1 plus kl. Equation 1 can be written as k rho, k psi. Equation number 1 can be written as k psi is equal to kw plus km plus ks into concentration of C minus CMC divided by 1 plus ks concentration of D minus CMC. Rate in aqueous phase, because Km is equal to 0, so we can write K psi into minus Kw is equal to Km Ks D minus CMC upon 1 plus Ks D minus CMC. On double reciprocal of above equation, we get 1 upon K psi minus Kw is equal to 1 upon Km Ks d minus CMC plus 1 upon Km. If I plot a graph between 1 upon K psi minus Kw and between D minus CMC concentration raised to power minus 1, then we get a straight line graph with a slope of 1 upon Km, intercept of 1 upon Km and slope of 1 upon Km, 1 upon Rm into Rs. Slope upon intercept is equal to 1 upon Ks and intercept is equal to Km. If Ks by some other method of kinetics is determined kinetically, then model is successful. Thank you, students. Catalysis of bimolecular reaction we will study another day. Thank you.